All right, Titans. Hello and welcome to Chapter 11, Section 2. And this is going to be the first part of Chapter 11, Section 2. I'm Mr. Spilker here, and I'm going to take you through two key points today. The first point is going to be your ability to evaluate a rational function. And the second one is going for you to be able to find undefined values of a rational function. Alright, so here in Chapter 11, Section 2, we're going to be working with rational expressions and rational functions. First of all, a rational expression is an expression that can be written as a quotient or a ratio of two polynomials. So in other words, you're going to have something like p over q, in which p and q are both polynomials. And you have to remember that q cannot equal 0, because if q equaled 0, then we would have an undefined fraction. So here in Chapter 11, Section 2, we're working with rational expressions and functions. Whenever you hear the word rational, just think fraction. So some examples of a rational function in the form of y equals p over q would be example number 1, y equals 3 over x minus 2. And then a second example would be y equals 4x over x squared minus 2x. So now that you know what we're going to be working with, let's get into two skills that we will be doing with these rational functions and expressions. Here's skill number 1, evaluating rational functions. Here the directions are to evaluate the function or expression for the x values of 1 and negative 2. So in other words, what we're going to do is we're going to take 1 and negative 2 and plug those in for x and find out what y is. So it's very similar to what we would do with just making a good old t-chart. You take the x values of 1 and negative 2 and you plug them in. Let's go ahead and plug 1 in. If we plug 1 in, we'd have negative 2 over 1 minus 1 plus 4. So let's go ahead and take care of the evaluation here. We're going to follow PEMDAS. So the first thing we're going to do is simplify the top and the bottom of our fraction. So if we simplify the bottom, we have 1 minus 1. So we would have negative 2 over 0 plus 4. Now, anything divided by 0 is undefined. Remember, if 0 is under, then it's undefined. So we'd have undefined plus 4, which you can't do that. That's just simply undefined. So if x is 1, the value of the function is undefined. Let's plug in negative 2. If we go ahead and plug in a negative 2 here, we would have, or excuse me, when it was positive 1, it was undefined, excuse me. If we plug in the negative 2 here, negative 2 minus 1 would give us a denominator value of negative 3. So we would have negative 2 over negative 3 plus 4. Now negative 2 divided by negative 3 would just be a positive 2/3. So we'd have 2/3 plus 4. So what's my answer going to be there? 4 2/3. So the first answer is undefined if it's 1. And if it's negative 2, the answer is 4 2/3. That's the first skill, your ability to evaluate a rational function. So you just simply take the values that you're given in the directions and plug them in, and you follow PEMDAS. Let's go ahead and look at the second one. Now the second one, they give us a expression here, but it's still the same thing. You just take the values and plug it in. So let's plug in 1. So we'd have 1 squared minus 5 over 1 squared minus 4. So I'm going to go ahead and start off by simplifying the top. 1 squared is 1, minus 5 would be a negative 4. And on the bottom, 1 squared is 1, minus 4 would be negative 3. And negative 4 over negative 3 simplifies to be 4/3. So if we plug in 1, we get 4/3. Let's go ahead and plug in negative 2. Negative 2 squared minus 5 over negative 2 squared minus 4. Negative 2 squared is 4, and 4 minus 5 is negative 1. In the basement there, negative 2 squared is 4, and 4 minus 4 is 0. Now, once again, you should remember this back from when we've talked about this first semester, and we've even mentioned it here in the second semester. Whenever 0 is under, it's undefined. So what's the value of my second expression when x is equal to negative 2? Undefined. Just remember, if 0 is under, it's undefined. Alright, now we're going to get into skill 2, but before we get into skill 2, we need a little bit of prerequisite information here. The first thing we want to talk about is what characteristics does the domain have? Remember, the domain is your set of x values. So what characteristics does the domain have? Well, when you think about the domain here with these rational expressions, the domain is always going to be all real numbers that give you a non-zero denominator. So the only values that are going to be excluded from your domain are those values that make the denominator 0. Now, if the denominator is 0, then you need to understand that the function will be undefined at that point. Now, what that's going to look like graphically will be explained tomorrow. But what I want to give you a little bit of a heads up on is that whenever you have an undefined value, you're going to have a vertical asymptote. Now, that asymptote is a new word for you, and that asymptote is a vertical line that the graph comes close to but never touches. And on tomorrow night's teaching video with Mr. Simpson, you're going to talk about those undefined values, and you're going to be plotting them as vertical asymptotes. And a vertical asymptote, once again, is a vertical line that the graph comes close to but never touches. Now, we're not going to go as far tonight as graphing, but our second skill is just for you to simply be able to find the undefined values of the following functions. So, for example, if we had 1 over x, remember that the domain includes all real numbers except those that make the denominator equal to 0. In other words, those values that make it undefined. So, the second skill is for you to find the undefined values of functions. So if you want to find the undefined value, you just have to understand that the denominator can't equal 0. So to find the undefined values, all you do is you simply take the denominator, set it equal to 0, and solve the equation. So to find the undefined values of example number 1, I take the denominator, I set it equal to 0, and I solve. I can solve this one by factoring. I could pull an x out, and then I could set each factor equal to 0. And what are the two values that make number 1 undefined? Well, 0 and -6. So the two undefined values for this function are 0 and -6. All right, let's look at the second example. Once again, to find the undefined values, you take the denominator, you set it equal to 0, and you solve. So what value would make the denominator equal to 0? Well, 2. If you had x value of 2, 2 minus 2 would be 0. So what are the undefined values for the function? There's just one, 2. All right, last example. Once again, to find the undefined values, here's the key teaching point. You take the denominator, set it equal to 0, and solve. Now this one I have a trinomial. I'm going to solve it by factoring. So it factors to be x plus 5 and x minus 4. Remember, when we solve by factoring, we factor, split, solve. So if I split and solve, my answers are going to be -5 and +4. Those are 2 points in which you'll have undefined values, meaning when you graph, you'll have vertical asymptotes. So the key teaching point here with skill number 2, ladies and gentlemen, is this, and you should write this down. To find the undefined values, you simply take the denominator, set it equal to 0, and then solve that equation. Keep in mind, if it's a quadratic equation, you'll most likely be solving by the factoring method. That's the most common method that is seen. All right, ladies and gentlemen, those are the 2 skills. Hopefully you enjoyed this teaching video. I tried to use my electric personality to teach it. If you have questions on this, feel free to rewind it. And then if you have further questions that you can't get answered by the video, bring those to Mr. Simpson or Mr. Spilker's attention, and we'll do our best to answer them. Thanks for listening, Titans.
Made with Doodlecast Pro.